Churi, feel free to start your talk. Thank you.
Okay, thank you very much. I would like to share the slides. How can I do it? Share screen. I have one participant can share at a time.
I think I already give you the co-host. You can directly click the. Can you click the button, the share screen button here?
Okay, share screen. But oh, okay.
Oh
so
yeah. Okay.
Yeah, that it should be okay. Share.
Yeah. Okay.
So you can see that one.
Right.
Okay. So, but I need to share the audio as well. So
yeah, when you click the share screen button, at the bottom you will have have one option that is share audio.
Okay.
You can just
okay. So I have the share sound here and the share. So now audio.
Probably if you can do a quick test actually. Just play again. We can check whether you have the sound.
Okay, share the. Let me and share. Okay. So to share the computer audio, please install the Zoom audio devices. Before I can, actually play the videos. But okay, let's start. And
okay,
maybe. Okay, so let me talk about the human perspective, seeing, understanding via multimodal sensing. So Mitsubishi Electric Research is located near MIT. So
oh, sorry, we cannot see slides missing. Probably you can. You close the sharing. Yeah, you can just click the share screen and share that. Yeah.
Okay, so share. Cannot share. So means that. Okay, so I tested in the morning. That was okay, but seems like it cannot work. Okay, so share the screen and the audio. I cannot play audio here. So okay, so let me introduce. Can you see?
Yeah, can see.
Okay, so
yeah.
And the presentation you can see.
Yeah, good.
Okay. Okay, so our research laboratory is 30 years ago funded by Mitsubishi Electric, and we have 50 PhD holders and working on the wireless communications, signal processing, and audio video processing, and spoken language interfaces, and also computer vision and mechatronics, many other topics we covered. And we are intensely working on fundamental research in Boston. And I have here is my research history. The most important thing is actually I have worked in speech recognition for a long time. Based on that speech recognition, I built this speech translation system at CMU with Professor Weibel and spoken dialogue system for Asimo, that is humanoid robot we built. And right now I joined the MAL to build the multimodal scene understanding based dialogue system. That is my research background. And as you know, so we have many smartphones and we can extract the information via dialogues. How do I get tumor from Kindle? Like a system can respond to our questions, our request based on that the knowledge in the internet or knowledge database. And gradually the dialogue system is stepping into the Internet of Things sensing data, and we have more rich conversation can be done. And in the next, robot system itself is they can hear, they can see, they can speak, they can walk and they can dance. So why not? Let's have much rich conversation freely. This is a concept. And what is a human-machine interaction? This is I'm doing to take care of the greens, and next to me, the robot is pouring the water to greens. And if he can recognize I'm falling in trouble, so he proactively asked me, it's too high for you. Do you need help? So definitely I said, yes, please take it down. this conversation can be done if the system can understand what's going on surrounding us. But when we would like to build such a system to communicate with humans and machines, first of all, humans understand the scenes using natural language. So in that case, machine themselves needs to understand scenes using language itself. This is because their understanding is based on numerics, and that cannot work for humans. So we need to let the systems understand scenes using natural language, and finally we can communicate together. And here is an example, and a robot and humans talk. And the man said, "That's a cool robot," when he looked at the two robots, and his mind, rounding shaped robot is cool. So in this machine case, robot just sensing the information and trying to output sensing information that it's numerics, it doesn't work. So in that case, we really need semantic understanding. And that is a video description. So here, the system recognized two robots. One is the humanoid type and the other one is round type. But still, that cannot be respond to the man's input. So the system needs to understand the scenes, and also the system needs to respond to counterpart's speech. So in that case, which one, the humanoid or the round one? So that question is better to respond. So if we would like to build such a system, we need the spoken language understanding and also multimodal scene understanding. In additionally, we have to create the response generation mechanism. So let me talk about the history of artificial intelligence research. We have a domain, the speech recognition or dialogue management, and computer vision. So this is the first generation of AI boom. At the beginning, okay, so speech recognition field. So first of all, we have to think about features, what types of features good for speech recognition. Capstone is proposed, and the sequential decoding needs to be done. So B-type algorithm, beam search was proposed. And the most promising invention is noisy channel model. So then we can gradually recognize phony and the word sequence, and the target could be the speech command, isolated word to sequential word sequence, like a newspaper reading speech. And in the computer vision, so this is a computer vision field. I don't have to step in the detail, but extracting 3D information about solid object from 2D is the mainly target in this era. So the second AI boom, actually for the speech recognition, acoustic model is the most important thing, and the hidden Markov model is very promising approach to apply. And the weighted finite state transducer decoding long linguistic model and acoustic models based network. So we can get the better performance. And the target becomes much bigger, broadcast news, large vocabulary speech recognition. And more step in that's much more difficult acoustic signals, like a call home, like a spontaneous speech or lecture speech. So when we think about the neural network, so first lecturer talked about the neurophysiology things. So people believe that the neural network in our brain can help the system mechanisms to recognize things. And in Japan, Professor Fukushima proposed the neocongruent neutron for handwriting. So that works very good. And this research gave impact to the speech field. So time delay neural network was proposed by Professor Weibel, and but still ATM was too strong and the neural network not applied. But this TDNN gave an impact to the convolutional neural network, that is 2 dimensions. The TDNN was expanded to build the 2D information signals here. And then, so right now we have the break for the neural network. Suddenly 10% of errors are reduced by deep neural network-based acoustic models. The systems becomes a hybrid. So acoustic models are deep neural network, but the decoding part is a WFST-based decoder. And then, so sequence to sequence model for machine translation was proposed by Professor Cho. So that was really great impact in the field of speech. We can build the speech recognition end-to-end format. So that is great. And in the field of computer vision, of course, object recognition and semantic segmentation and video captions and many action recognitions are investigated. And task variation is really exploded. Static image and video processing is targeted. So, but still, all of the, the network is a convolutional neural network. And this is a third generation AI boom. And when we think about the dialogue, so actually dialogue was built as a handcrafted system, but handcrafted is limited to, so people start to think about how to build the statistical approach for the dialogue system. And now end-to-end dialogue system is intensely worked by many researchers. Okay, let me talk about the handcrafted scenario here. That is FST-based dialogue systems, state and arcs, and we can change the state to output the responses based on the state. But that is human needs to write this network and really tedious work for this one. So we implemented the Enneagram-based dialogue system. So we annotated all of the data. So, and then we can generate this type of network. So statistical models for the guide action simulator and the hotel clock simulators. So rule-based one is a left side, very simple. But when we analyze the human conversation, its networks looks like that, and it is too much. So when we would like to scale up the training data, actually annotation is too much. So we need to minimize the effort for the manual labeling efforts. So that's the reason why people start to think about the end-to-end framework and the deep neural net models with continuous state space can allow us to build the system without human annotations. So in 2014, sequence to sequence model was proposed like this, and I believe that people should know this framework. And then so Google, so Bineo proposed the neural network conversation system that is whatever system says, people say the system can output in response to users' input. So this is a really promising result. And we decided, okay, end-to-end framework works for the dialogue. And we collected the data from the customer service. And we try to generate the system response using the data set training data by collecting the Twitter data. And we run the challenge sentence to sentence generation task. So surprisingly, we didn't give any domains into the system, but system automatically detects that, okay, this is a McDonald's, this is Honda's car issues, like all of, system needs to the target, and the words are selected based on that domain. So we didn't give that the explicit topic or domains, but the system automatically learn about the such information automatically. And then, so we are working on multimodal scene-aware interaction. This is a milestone. First of all, our target is scene understanding based on navigation, follow silver curve turning right. And that is, we have to build. First of all, we needed to build the neural dialogue systems. And then, of course, the system needs to understand surroundings. Video description technology is required. And after all, we combined two systems into the audio visual scene aware dialog. And finally, we can build scene aware interaction systems for the future cap navigation. And the system is shown in this figure. So microphone, camera, sliders, multimodal sensing information input in the end-to-end system. The system has a function for the attentional multimodal fusion for each signals, and seeing, understanding, and a natural language generation is simultaneously processed in the neural network to generate the responses. And this is actually the demo system from our side. So this is mainly based on the computer vision features here. So, but so I think I cannot broadcast the speech synthesis here. Text to speech is generated. So the warning is output as a speech. And then, so that is a more, we have an interaction here. So I cannot broadcast the audio. It is meaningless to play this one. Let me play this one here. So here is the features we have used is bounding box-based object recognition first, and then semantic region segmentation was done. And the most important thing is we needed to track the object. Bounding box tracking was done here. And the difficulty is actually when we try to explain the scenes, we need to understand the object localization. So the bicycle is behind the cars or behind the peoples. So this type of things needs to be localized, but unfortunately, the 2D image cannot give us such information accurately. So in this case, we would like to show that multimodal feature extraction for a mobile mapping system that is point clouds is captured with 2D images. So the system can give us the point cloud view and the top-down map, and also original video, like 2D images. We can align the point cloud view to original views. Finally, we can localize the building is located where. So, and then we can build the dialog system on top of these informations. The problematic thing is actually, I was shocked. It was my first time to work in that visual informations. So every frame has a different bounding box. So it means that we really needed to track the object. That issue is very huge to be solved. And if we can solve all of technologies, so we can build the surveillance camera systems to recognize, okay, suspicious actions near the station, like even if we have 2,000 cameras, the system understands what's going on. And of course, we can build the dialogue system, like instruction videos to show that one. And there are many kinds of things we can do that for this domain. And so from here, I would like to talk about the technical portion for that one. So sequence to sequence models, so that is machine translation target, alias TM encoder decoder, which proposed by Binios, and the attention-based encoder decoder, which proposed for machine translation, and also transformer. And this technology is currently main approaches we are using. And those approaches were widely used for various kinds of tasks: speech recognition, machine translation, language understanding, dialogue, video description. The difference is just input signals and output signals. And finally, I recognized that I have worked on spoken language processing field, and finally, okay, what types of signals, whatever, I can input the system, so the system can generate sentences. So sentence generation is the target of my research life. So here is a LSTM encoder decoder. So this is actually very famous, and the input signal word sequences input, and we try to transfer that dependency between the previous context to next word. So word by word, we are trying to predict. And then, so attention-based one is, of course, just to rely on the previous word is not enough. So we would like to rely on the, all directions. So in that case, attention let us know which word is dependent on which direction. So we can generate much accurate sentences based on this framework. And then transformer. So feed forward a network with residual connections in able to learn very deep architectures. So the most important thing is actually we would like to see whole dependency in a sentence or in a context. So that transformer will let us to see the context for full size of the data, that is full size of sentence. That is very nice to use it. So, and then large-scale pre-trained language models for various sequence-to-sequence tasks in natural language processing. So I think everybody has already known about the BART and the GPT-3. So the idea is they collected tons of data from the all possible document to build the language model. And BART case is a mask language model to detect the surrounding word sequence. And the GPT-3 case is actually that is a simple language model, transformer language model to detect the next word. And GPT-3 proved that on the radio, I think social media automatically responds to the human's input, but the system can accurately respond to the chat in the chat, and the people believe that that is not since that is humans like. And when we applied this large scale pre-trained language model, we need to tune the parameters using the target data. So fine tuning is required for that training. So it seems like it's a kind of breakthrough to apply this one to enhance the performance, especially GPT-3 has the power to handle the machine translation or dialogue or speech recognition. Many domains are covered, and actually they didn't input the explicit task in there, but the system automatically judged that it is machine translation, and the system generates the target language translation results. Okay, so, and then, so I started to work on the multimodal understanding, and finally semantic representation needs to be trained using audio, video, and text features to improve the performance by cooperating with multimodal features. And this is a video description which was proposed in 2014, and very simple. the convolutional neural network feature is extracted and input into the encoder, and the decoder generates the sentences. That is a fundamental framework for the video description. But when we see this framework, actually computer vision guys are focused on the visual feature only. When we try to apply our technology to the real world, we need the audio features as well. So let me talk about why audio feature is important. So this is a scene of the object recognition and sentence generation for the scene. First of all, image and localization features will let us know objects and their relations. So in that case, girl and hill. So that will let us know a girl is standing on a hill. And then she's jumping. So this is a spatial temporal features, motion and action, and we can generate a girl is jumping. So the third one is a guy sit on the hills and look over the sky to see the airplane. And the image and the localization features can generate this sentence, but airplane is gone. And suddenly the sentence is, our girl is sitting on the hill, but that the description is not right. So how to generate the original sentence? So still we can find the sound here. So when we combine the visual features, audio features, and audio feature can be considered as a part of features. Actually, we can generate a girl is looking over the sky at an airplane flying overhead. So this sentence can be generated. So multimodal fusion has been already studied in the research field. So long-standing area of research, how to combine information from multimodalities for machine perception. So in 1998, Bayesian adaptation approaches were proposed, and the stream weights was also proposed. But neural network has been already investigated, and all of the informations are combined into the one network. So I think the first to fuse multimodal information using attention between modalities and neural network in our research. And then the idea is very simple. We have the modality 1 and modality 2 to combine together. And normally we just join naive manner, and we can pay attention to the temporal attention and to generate sentences. That is a naive fusion of modalities. And then we can expand this idea to weight between the each modality. In our cases, audio and visual features we have, and we pay attention to between two modalities. And we can generate sentences word sequence based on selectively attends to specific modalities. And that is actually samples. And I would like to let you guys to listen to the sounds, but unfortunately I cannot broadcast the audio. So the first one is actually visual information is very strong to generate the monkey pulls the dog's tail. But when we have the VGG and the C3D, still we have multimodal attention between two modalities, the performance is better. And when we listen to the onion, cutting onion on the peeling onion, actually the system recognizes the sound of peeling to add more weights to the words. The system can generate a woman is peeling an onion. The problematic things for the YouTube video, look at this one is riding a horse scenes, but the music is, the background, they have the music. So country music in there. So in that case, if the riding horse scene always have the country music, there is a strong contribution support to show that the riding horses, but not always. So in that case, that is a kind of noise for the information. So that is the most difficult part. And the other one is, this one is actually, he is playing the violin like a guitar, and the system cannot recognize without multimodal attention. First, we just using a visual information, a man is standing. So actually this is singing, that is microphone is strongly recognized to support this sentence. But when we use the audio features, suddenly the system say that Aman is playing a guitar, but still there is no attention between two modalities. There is no way to find the violin and the guitar. Seems like when we applied the multimodal attention, the system can generate the guitar. So a man is playing violin. That is very cool when we built that one. So attention modality fusion works very good to generate sentences. And we analyzed what types of words are weighted by each modality. So when we see the object recognition features, we have a ball, pen, recipe, almost none are well recognized. And the motion part is recognized by the C3D features. And we applied the MFCC for the audio features. And when we see the weight between other visual modality and audio modality, actually audio features has a slightly not slightly that is 0.34 means that drastically changed. The visual is much more strong powers, and audio features is supporting a part of word sequence. Looks like talking, Sean playing, singing. So sound related. The action which has a sound, those are words recognized by audio features. And now let me move on to the next step. So if we can recognize scenes using a multimodal features, the next step is a dialogue, audiovisual scene aware dialogue. This research target is actually we collaborated with Georgia Tech. So they have already worked on the visual QA, so static image. They let the people to ask questions and answer answers to response to the static images. And but still, that is a static image-based question answering. And we would like to work on the video features. So we extend their framework to the audiovisual scene aware dialog. Video is input, and the people start to discuss about the videos, and we have to generate responses, answers to humans' questions. And then audiovisual scene aware dialog is collected based on that the two humans dialogue. So one questioner cannot watch the full video, and the answerer can watch the full video. And a woman is seen snuggling up to her laptop. She starts taking a sip of coffee and begins closing her laptop. That is a scene description, a scene script. And but actually answerer knows about the video and the script, but questioner don't know about. The questioner just ask a question to figure out what's going on in there. After question answering, 10 question answering, the questioner needs to generate the summary of the events in the videos. So it means that questioner needs to collect more information in that videos. And this is the result. So 10 tons of the question answering, and they can figure out the question and figure out what's going on in the videos. And we are trying to generate the responses based on the context of the dialogue and questions. So we can have the target, two targets here, sentence selection or sentence generation. The task for the sentence selection is a kind of information retrieval framework. So we prepared the multiple answers, and we select the best answers from the multiple answers. That is the task. But the problematic thing is my difficulty depends on how to prepare the multiple candidates. If the candidates itself is very different and easy to select, so in that case, task can be a very easy task. And the sentence generation case, so speech recognition and a machine translation framework is applied. And the difficulty is determined by the perplexity base entry of the word sequence. And the answer generation itself is depend on language model. So if language model is trained to question answering tightly, that is limited to only to the text in the training data. So we needed to figure out the difficulty for each task. And in our case, ABSD, we have two kinds of tasks in there. And let me describe the mainly sentence generation part. So when we see the distribution of the word sequence in the ABSD, so questions mainly, does he see this is action related to questions, and what does she, what does he, that is also action recognition, but some of them are object, what is this? None was asked by the humans, and some of the questions are related to the audio. So, and the ABSD sentence length is a little bit longer than other question answering systems. So here is a baseline of multimodal dialogues. So first of all, so audio-visual features input, that is video description power is embedded in the systems. And also question needs to be in there. And the context needs to be considered. Okay, what types of question answering has been already done, and the context has been already embedded. And based on that, the history question needs to be understood. So this is a framework. And also we have a script and summaries given by questioners. So that is, those of them are describing scenes. We would like to expand the text knowledge, so we input the descriptions into the systems. So that is the challenge was done in 2018 and 2019. That is Dialogue System Technology Challenge 7 and 8. And so violin plot shows that how much the system can generate the good systems. Number 5 shows that the size of the balloon is the number of right answers in the 5. So left bar showed that the differences, and others are systems input. So in 2018, most of the systems are very poor. It is very hard to compete with the human result. But 1 year later, suddenly the system performance is really great, almost comparable with humans. So the reason why such a thing happened, so let me describe. So those of challenge, actually, we published the journals, special issues. You can find the papers in the journals to see. And this is DSTC 8 best systems. Actually, I'm very shocked. So everything is embedded into the systems. So transformer was applied, and the audio video sequence modeling, caption language modeling, and lens response language modeling, everything is put into one neural network to transformer and generate sentences. And that is the best systems. So it seems like if we have the video description, we can generate answers accurately. But unfortunately, so in their use case, we don't have the video descriptions, manual video descriptions. We cannot input such a good information in there. So in that case, we needed to have a power to transfer the neural network, which have been already trained using a description and questions. So that is the right side, teacher network. And we jointly trained the network, student network, which doesn't have the description and the questions. So definitely student network cannot use the descriptions, but they need to get the comparable performance using the description. So student teacher like framework is required to embed the video description power in the dialogue systems. And then, so this year, we are organizing a third edition of Audiovisual Scene Aware Dialog Challenge at DSTCTN. So the idea is, okay, answer generation cannot use the video description, manual video description. Don't use the manual description, just use the audio visual feature to generate the sentences. At least we can get the question answering history. We can apply that the information in there, but video description power needs to be embedded in the different manner. So, and then we finally recognize there is no reason to generate that answers. Sometimes, audio features, visual features, we don't know which segment is contributed to that, the answers. So it means that we need to figure out answer reasoning temporal localization. So, and then we can rely on that, okay, this answer is not generated based on that language model. That is more, feature-driven event detection has been implemented in the systems. So now we are collecting the data. Data is manual data annotation was done. So we let the people to watch the videos and the people try to read the question answering. What actions are taken by boy? So when we see the videos, a boy is riding, looking at the grass and holding it and drinking a glass of orange juice. And also he is singing a song from 10 to 20 seconds. So the answer is the boy is riding and singing and then drinks a glass of orange juice. All of events needs to be supported by the evidences. So the humans needs to find the event the boy is writing in the notebook. So from 2 sec to 20, that is a visual features. And the boy is drinking from the glass from 30 to 40, that is a visual features. And also the final question is, evidence is the boy singing rock music, 10 to 20 sec, so audio features. Those things are annotated. And we can use those data to train the models and to detect the evidence to generate the audios answers. And here is the schedule. So right now we open the answer generation data release, and June 30th, we are going to reasoning temporal localization data, and let's start to train the model to submit the system in September. We can have the workshop in January and February. So please come to join us. Okay, thank you very much.
Oh, sorry, I just forgot to unmute myself. Okay, thanks, Tori. It's a really nice talk. Clear roadmap and several interesting topics are covered. And also, if you are interested, please join this challenge and to train your models and submit and to see whether you can obtain certain awards. Okay,
Yeah.
probably, yeah, we can take one question here. I can give the permission. You can unmute yourself, or you can post your question in the chat box. Yeah, so feel free to ask that questions. Okay, yeah, there's a people see that. Yeah, please. Oh, I think you can unmute yourself. Hello? Yeah. Okay.
Sorry, I couldn't unmute myself initially.
Okay.
So my question is that, so do you, like you said that you extract the audio features, like he's talking, singing. Do you also like detect like what is the content of like how like if he's sarcastic or like detecting the emotions while he's talking or he's singing, then if it is a sad music or something like that?
So actually in this task, we do not work on that perspective. So, but of course, if we can annotate the data based on that, the emotional sentiment or, any other additional information, we can apply the training model by, multimodal fusion partner. But unfortunately, the most difficult part for us is actually collecting data. Annotation data is not, available for the all data sets. So if there are some pre-trained model which has been already trained all kinds of condition, maybe we can use that one as one feature. So of course, we recommend to the participants use the pre-trained model. We have, of course, we have two tracks. One is only limited data. The other one is publicly available pre-trained models use case.
Oh, mute. Okay, yeah. By the way, thank you. Yeah, thank you, Cherry. Due to the time limit, we just will go to the next section, but we will have the panel discussion. Please join us if you want to ask more questions. Yeah, thank you. Our next speaker is Di Hu. Di, could you share your screen?
Yeah,
okay.
fine.
Yeah, so can do a quick intro.